Very used to it. It was great when they had one of those 2-day presentations when you were growing up, because I was always on day 2, so I had an extra day to work on it. So my name is Jake Zarnegar. I'm Chief Product Officer at Silverchair. We're a platform company. So as a product officer at a platform company, I'm contractually obligated to talk about artificial intelligence, blockchain, and the Internet of Things in every talk. So I chose artificial intelligence in this one. Really, the reason why I'm talking about this today is that just as a platform host, we see who your users are. And to give you an example, we just launched a site, and it's doing about 5 requests a second from people, and it's doing 45 requests a second from bots, agents, and non-human traffic. And this is a large research publisher. So we're looking at how do we best serve that 45 out of 50. I know there's been a lot of talk about how to serve the 5, and certainly that is a concern that we always want to work on. But I want to talk just a little bit about how other systems interact with our data, and especially our indexing of that data. And the first thing I wanted to go over was artificial intelligence is ridiculously overhyped. This is what you get when you run a search for artificial intelligence hype. My favorite one is the last one, where they put together artificial intelligence and fake news, 2 completely overused concepts in the same headline. But I want to narrow it down just a little bit so that we know what we're talking about. And there's a great definition that I found here, which was basically saying, what are we talking about when we're talking about artificial intelligence, machine learning? Are we talking about simulation, where you're basically replacing a human? That would be something where you couldn't tell it was a machine. Or are we talking about augmentation? And right now, I think the most appropriate thing to talk about is augmentation. And this is agents that take a human and make them better at their job, better, faster, more complete. So that's what we're going to talk about today, and especially around the indexing. And if we look at the augmentation, there's really 2 players or 2 types out in the market right now. So there's the general augmentation, which are your kind of household assistants that are trying to answer any general question you might have, especially factual ones. And then we have these specific augmentation. So, teaching an AI to play Jeopardy very specifically. The machine you see on the far right there is in a museum. That's Deep Blue from IBM, who beat Gary Kasparov. That doesn't seem that long ago in my life, but it's in a museum now, so starting to wonder how old I am. And then finally, in the SDM space, they're developing very specific things like that story link right there goes to a system that is analyzing slides of people's dermatological condition. Is actually more accurate in diagnosing whether something is precancerous or cancerous than the human slide readers. So very, very specific training of that AI in a very specific set of scenarios, and it can perform or augment the job of a human. Now, they're not all great. I don't know, there was a lot of hullabaloo when Watson went into cancer, augmenting cancer researchers and cancer doctors, and it was less hullabaloo and less press when they kind of put that project on ice earlier this year at MD Anderson. So they're definitely, folks are trying to augment. It's not going to be an even path. It's going to be pretty uneven. And what we're going to talk about today is how can we help these systems be the most effective. So, just 2 more conditions here that I wanted to talk about is something that separates. One other thing you could say about AI is it's just software. The folks who are developing it don't want you to say that because it's new and special. But there are 2 conditions that I think folks generally agree on across all those crazy definitions. And one is that it does have an independent learning cycle to it. So it can interact with stimuli, whether that's sensors or whether that's just simply feeding or reading more information or crawling more information. And it can change itself by interacting with that without any human interaction. And then the second thing, if it's going to augment us, we have to be able to interact with it. So it does have to have some interface via, obviously the Cortanas of the world and the Alexas are a spoken interface. But there has to be some sort of interface with humans so that you can query it and it has an interaction with you, not just an answer, but an actual questioning back and forth. So what I wanted to look at today was how can we prepare content that will help these systems and not hinder them. We don't want what happened at MD Anderson to be the status quo with these AI systems. So how can we best prepare content for these systems that will help them? So one thing I wanted to jump into real fast is that you can't interview an AI system at this point. So we interviewed a lot of researchers who are using machine learning techniques and using them in STEM and scholarly to ask them about what are their hurdles, what could be done better for them. And a couple of them pointed me to this study that came out of IEEE. And it goes through the four basic steps of designing and running a data mining project. And I highlighted the second step here. You'll notice that first you have to know what kind of problem you're trying to solve. Then you have to gather data and normalize it into it where it's ready to be queried. Then you have to figure out what kind of nifty, neural net algorithm you're going to deploy on it. And then finally you get back results and you have to figure out what to do with them. And I highlighted number 2. And there's a reason I highlighted number 2, and it's in the next section of this research article. And that is, number 2 takes forever. It's difficult. And they noted it as 60 to 90% of the time in a data mining project is that data preparation and normalization phase. I don't know where they came up with these numbers, by the way. The article is a little, there's some guesswork going on. But certainly directionally, they also noted that 75 to 90% of the success of the project is based on how well the data was prepared for the project. So as the holders of scholarly and scientific content, this is our area of expertise. I mean, you've heard it from folks today on how we are preparing that content, normalizing it, linking it together, making it so that it can be interpreted by machines more effectively. So this is what I wanted to focus on today. Oops, went the wrong way. And just to throw in the human element, I interviewed this gentleman who runs data mining projects out of a New York firm called Fast Forward Labs. And I had talked to him right after he had downloaded the entire physics archive. You can do that, by the way. He had downloaded it into his program, and I said, well, how's it going? How's your data mining project going? He goes, I haven't even opened the file. He's like, I know what it's going to be like. It's going to be 6 months of trying to sort it out, normalize it, get it ready, and I just can't take it. So it's just sitting there as a file on my machine. So this is one of the problems that we're trying to solve for here. So I'm going to bring a taxonomy into this. It's a taxonomy that is 61 years old. It's called Bloom's taxonomy. I don't know if you're familiar with this. This was a taxonomy that was developed on the theory of learning for humans in 1956. But it is being applied and can be applied to the artificial intelligence systems that people are developing right now. And you'll notice that it is a hierarchy of complexity of learning, starting with simply remembering and recall, all the way up through understand, apply, analyze, and then finally creation being probably if you can create something, then you've learned it so thoroughly that you're able to create something new in that space. So I wanted to kind of map where we are with our content and our indexing on Bloom's taxonomy. And what I found was we're really good at the bottom layer, The internet is a remembering machine. So, I mean, you have to pay Google to forget stuff. So, so it's definitely default remember. I pulled up an article, which is a fascinating article, by the way. You should read this from the Royal Society. It's when 8-year-old Mozart came to England and was put through the paces by an English researcher, and he wrote a paper about it. Apparently he was a remarkable young musician. But you can find this article now in its completeness. It has been indexed. It has a DOI. We are really great at remembering and linking folks to the permanently scholarly record. So we're doing pretty good on the recall and the remembering piece. As we start moving up the chain to actually understanding what the content, not just being able to find the content and remembering it, not forgetting it. You'll see some of the words under understand: classify, describe, explain, identify, locate. This is starting to sound like indexing. So the more complicated indexing that folks are doing probably fit into the understanding, so trying to foster understanding, machine understanding. Now, we're good at creating understanding from humans, and I picked this article in a self-serving fashion because any pro-coffee article is a good article in my torch. So we're good at presenting the content in a way that you could quickly read it and identify it. And then for software, we're also have a pretty good foundation on this. So we are an industry that does normalize our XML for the most part. Marjorie, you were talking about JATS as being a very normalized state of what you're using. And certainly for us, JATS and BITS and other industry initiatives have helped us normalize the structural elements of content so that we can share them across each other. And we're also getting much better at indexing what I would call named entities. So people, places, things. In STEM, that would be everything from genes to clinical trials to people to institutions to researchers. Every day we come out with something new, like ORCID a couple of years ago, to try to get those named entities really locked in. But as Marjorie also mentioned, things can still go awry, and sometimes it's hilarious. We recently indexed a paper that had identified as Beth Israel, the hospital here in Boston, as a person. But not only that, but it made the great leap that Beth Israel got married and became Beth Israel Deaconess. I haven't met Mr. Deaconess. But clearly it was making these leaps from what it thought it was finding in the content. So having indices of, say, institutions would have helped us disambiguate that as well. Where we start to fall down as an industry is when we're trying to go further up that cognition or that education train. As we move up to apply and analyze, you're starting to see new words in here like interpret, implement, differentiate, compare, contrast, distinguish, examine. But folks are starting to do it. We're starting to see some pretty interesting sections in the content that's coming up on our platform. And one of my favorite here is on the left, the American Society of Anesthesiology. Is there anyone from the ASA in here? All right. Tell them they're doing a good job. One of the reasons is they've added this section to their journal articles, which I hadn't seen in other journal articles before. And it says, well, sure, you have the whole article. You still have the abstract and all of the keywords and all of the indices. But they also wrote a section here. What do we already know about this? And what is new in this article? And that's a pretty fascinating approach to summarizing. Because it puts you in context and it references other bits of knowledge that could potentially be hooked in for systems to add only the new stuff and maybe verify some of the previous content that it had found before. And on the right side, we're getting even shorter summaries here. So this is in a rheumatology journal where it's taken a summary of even the abstract. So they're trying to put this content in context of how to interpret this journal article. Now, the reason that I'm interested in these sections is that people have a kind of, I don't know, I wouldn't call it a blind faith, but people have a kind of arrow of technology progress faith that machines are just going to eventually be able to make this section. and write it itself. But we're not there yet. So the more input and the more structured input you can get into these machine techniques, the better they can perform on the back end. So the one sad thing about this section right here is that it has no distinctive tagging. It has no distinctive XML tagging. It's a section, it's a bulleted list, it has a title. It's not separated out from the other tagging saying, hey, this is a really amazing section, machines. This is the section that's probably going to tell you more about the paper than all of the other sections, including the title. So we haven't quite made it there with the tagging yet and the indexing to get what we can translate in a visual way into something that the machines can crawl. So where we're still not helping as much as we can is that, again, we're using visual interfaces. We actually, most folks are not sharing the underlying XML by default. I think open access publishers are a little more okay with that. Certainly a lot of subscription scholarly publishers are not so eager to provide the entire XML. I mean, obviously things like Sci-Hub are built with PDF. Imagine if they had all of your XML as well. I see someone cringing over there. But is there a method here to do that? And then finally, we're not indexing above that understanding level yet. We're not trying to put in more judgment style indexing in that application and interpret zone. So these are three things that are holding us back. So where are we going? So we're going to go back to this taxonomy. And the last slide said it's a race to the top. It is a race to the top. If you find yourself in remember and other folks are in understand, apply, analyze, evaluate, you're going to be left behind. The next generations of systems are going to be doing remember, understand, apply just by default. So there's kind of two paths that I see for scholarly publishers on how they want to prepare their data, index it, and then also share it. And one of them is to play ball. Consider deeply indexing your content and then producing it as a new product. So you have your human interface readable product, but you wanted to create a product that is not for humans, but for these agents. And if you were to do that, we talked to the data miners, and they gave us some pretty strong guide rails. One of them was, give me the whole XML. Don't try to manipulate it, cut it down, start processing it yourself. Give me the whole thing. XML is great. Also, JSON would be cool. And then give me a separate delivery mechanism for this. I don't want this in a human interface because I don't care about your human interface. I'd like to get the whole corpus into my system so I can mix and match it with other content and run my routines on it kind of at will. So a lot of the data miners says, just give me the content. Now, that may or may not be palatable to publishers. The last piece here is pretty important because if you let your whole corpus of XML out of the house, certainly you're going to be concerned about where that's going to end up. But that is what the researchers want. They don't want to be crawling your system and waiting for your system to respond and going through your visual interfaces and trying to crawl your HTML and figure out what was what on there. They want your enhanced XML and they want it now. Why would you do this? I probably should have highlighted this button. So we are seeing some of our customers being able to make deals with systems and buyers that they had never been able to access before. So not traditional library subscribers, and not even traditional corporate subscribers, but people who are developing this next generation of tools wanting to buy this content to feed into their tools. So in geoscience, for example, exploration geoscientists would want to purchase this so they could bring it into their data mining systems. And so there's a lot of money flowing to those new organizations. They're likely more well-funded than libraries. So if you can bring in those types of customers, there potentially is a way to reach a new class of customer with your content. By the way, evidence from the 45 out of 50 requests per second coming from this, they're already your customers. They're just not paying you anything at this point. They're crawling your content. They're using it in their systems. So if you wanted to take them and say, you know, crawling my HTML from the front end is horrible for you and me. Why don't I provide another product for you that you can then pay me for, and then we'll both walk away happy. By the way, I will help you with this, because you still have this problem. So if you're spending, I got to work on one of Marjorie's big ROI calculations, but I'm sure I could take a project that they're spending. By the way, data miner and data are not cheap. So if they're over there normalizing data, that's a really terrible waste of someone you're paying a couple $100,000 a year to. So if they're spending 6 months on that, imagine licensing it in for cheaper than that, pre-prepared for you. So there is an opportunity there. But there's another path that you also might go, and that is don't share it. And build your own applications that walk their way up Bloom's taxonomy. So if you do want to provide your own services that have more analysis in them, that do more with the content, then frankly, I wouldn't share my content out to others just to compete with you with the same content. Publishers do have the keys to the castle, so to speak, for some of this content. And so it's their choice about whether they choose to let it go out of house for other people to develop on top of. If you have the capabilities and the competency to develop these next systems yourself, then that's also a method to do. And I believe that's it. All right, thanks, Greg.
All right, that was our last presenter. I'm going to ask the panelists to come up and you can ask questions of everybody. Bob Doyle decided that he was going to leave early. At least we got any questions for him. Okay. I'll list up here.
Yeah. You need a spit bucket?
We have no sense.
Yeah.
Andy with the towel.
And we can pass these microphones along. Okay.
Yeah.
Any questions about indexes, taxonomies, thesauri, automated indexing, and so forth?
So a few people mentioned Google sort of in passing and Google search, and it strikes me that Google must be doing some of this stuff themselves, and I'm wondering how much insight you have into how Google is using some of these technologies, and how does that influence how publishers might want to think about what they do or invest in themselves versus, you know, kind of just letting Google do it?
So as you probably know, a few years ago, publishers didn't want Google anywhere near their content, and now the first thing they want to do is make sure that the site is Google enabled so Google can crawl it. But the difference is that what Google is doing is based on literally billions and billions of information objects at this point that they can compare and control. They also have a heavily ranking system. So the taxonomy at Google, which is only in use at Google Scholar, is about 200 terms. Just in case anybody wondered, it's really awful. But you can well, it's not as easy to find now as it used to be, but it is on Google Scholar. So the techniques they use, because they have such a huge amount of content and they have such a large amount of users that are favoring something by clicking on it, they have a voting mechanism in there that publishers don't have. So if you have even 1 million or 6 million, although I think the average publisher has more like 200,000 articles, you don't have that breadth to enable the kind of statistical application that Google has.
Well, and I'll take it from a different perspective too, is we've all done a Google search where there's that pop-up that shows up on the side. It says, hey, did you know Galileo? This is all the stuff about Galileo. So that is their knowledge engine, right? So all that is an ontology. So all publishers can create one. You just have to know how to do it. And a basis of that you really do want to start with is instead of using just the search index, which is very messy and a little crazy, is you start with the actual vocabulary that you have, and then you can start building off of that, or you can work with a partner to do some of those things.
Google is awesome. I hate them. I mean, Google's incredible, right? I mean, what can't they do? They're going to have more resources than you. They have more computing power than you. They're going to have better engineers than you. What they can't do is get really, really deep into a discipline that might not be that interesting to them. So that gives us a stay of execution. And it also gives us a chance to try to stay ahead of them. But staying ahead of Google in the long run is a very, very difficult thing, and it might be, it might be impossible. But I do believe that a lot of our publishers' business models rely on them being better than a general Google search, being better at suggesting what someone should read next, and being better at matching the folks to the concepts that they're looking for research, not just the terms. But in the long run, no, it's a tough battle, and we will likely lose.
I think the real challenge is once Google has gotten a searcher to your site, keeping them there. I think that's probably the broader challenge, and to me, that's where making search really effective and bringing them and keeping them once they've got there. I think that's the better challenge, leverage what they can do.
I think one of the advantages that Google has besides size is the fact that you mentioned, like having Galileo on the side. We are used to Google totally blowing it, and yet we don't give up on Google. But when you go to a vertical discipline with the deep knowledge, if they totally blow it, that's really, really annoying. So one of the disadvantages is Google, people are used to screwed up results, whereas they go to your vertical knowledge site, and that's really a black eye. So you have to kind of be careful there. And then I'd like to, maybe something you mentioned, Ashley, slight twist. Is Google teaching us how to search, or are we teaching Google how we search?
It's both ways, I think. It's both ways. One thing I do want to mention, and it kind of builds on what you were talking about, is that, is as far as why people get more crazy when you guys mess up, and it's because you're the folks that are saying you're the subject matter experts. Google is not. So when it messes up, it's like, oh, well, maybe it just didn't understand, maybe, So you make these excuses when you're doing a Google search because it's Google, it's huge, it doesn't understand that deep knowledge. But you as a publisher, if you're doing stuff just with mathematics or just in philosophy, they expect you, users expect you to be the experts. So if you mess up, it's a discredit to you rather than they just had messed up data. So it's a little bit of controlling expectations. So if you do have something that's a knowledge-based kind of stuff, with Galileo on the side, something like that, just make sure that you're very upfront with your users what that actually is and what they can expect from it, because they're going to expect it to be Google without the issues that Google has, right?
Okay. Do we have another question from anybody? Change the topic if you'd like, or Sorry, I did misspell your name here.
Me?
No,
Oh.
Margie.
Tom has
No,
it.
no,
Yes,
I
you
said,
did.
yeah, I'm sorry. I'm sure Google would correct it, but it's Margie with a J. It's because we do Margie as a nickname with a G, and I mix them up that way sometimes. So,
Good clarification. My question is about auto-indexing, and I'm interested in sort of at what point you would recommend pursuing that. So I have online content with about 175,000 objects. So am I too small to do it, or when do you decide to dive into that?
I might just say one thing here. It's not just a matter of the size, that's one of the factors. There are multiple factors. I mean, there's what's your turnaround time? I mean, it's automated, once it's set up, will go much faster than manual. I mean, but see, often scholarly, it's not necessarily has to be as fast. It's like, news or something. So that's another issue, is that the turnaround time. And sometimes it's even just the culture of the organization. I mean, are you technology focused? Are you kind of more, human intellect focused? And that's another factor. Where do you want to own the technology? Because manual indexing software is very low tech. You can do it yourself, where the automated, you need to license, you need to have a relationship with a vendor. So that's just part of it. Aside from, the ROI, I'm very glad that Margie explained that. Then you can start figuring out those things as well. So that's as far as I'll go, because I'm not everybody here is more technology oriented than I am.
I think there's also depth of indexing, depth and breadth and type. So we kind of focused a lot on conceptual indexing, but that's not it. I mean, there's people, places, things, all those pick lists and so on. And there might be, not knowing your specific instance, but in the medical field, you might do it by disease or procedure, and there's just a whole lot of different aspects. So it depends on how rich you want to make that content, how much you might add. The smallest collections I know of that do automated indexing are about 20,000 records, and they go up from there, and throughput is important.
Okay. And
Can I
just
ask
for
which domain you're from?
Yeah, so just for context, the content is for developers who are using, it's a corporate software company. So for developers who are doing an implementation and trying to solve problems, they're stuck and they're getting tech support and help documentation.
Yeah, so something that I would just throw out is if the people that are using your system are looking for answers, then an index is only going to get you so far. Taxonomy is only going to get you so far. So actually creating more of those mappings will help you with inferencing. So that's more ontology, right? So if I ask a question, what is the capital of the United States? Google will tell you it's Washington, D.C., and it's because there's something that's in there that maps those two things together. So you can do those things to start helping your users answer some of those questions. Now we're getting into more, what does Google do? Google does this way better than anybody else because they have so much data, but that doesn't mean that your users won't ask specific questions just for what you're offering. So to do that really well, you need to do some automation.
Yeah, I think the mapping and the decision tree stuff, you're getting more into linking of different data parts. And although there's heavy focus today on linked open data, I would say the bigger uptake of linked data is actually in organizations. So they're looking at all the academic linked open data jazz, and then they're taking the open out of it, using it in a closed environment. But those the methodologies, the systems that have been put in place work very well for both, and they might well work for you in your organization, because then you can put like things together.
The only thing I would add is that just about ontologies, the one thing that's cool that they really add is not only do you have the labels acting as targets for searching, but also the relationships between the labels can be whatever you want. So you can define how certain things are related to other things that meet the needs of your user base. So if you're getting a lot of questions on a certain topic, you could link the things in a way that answers that particular type of question. And the link itself, the relationship that those two objects have, would be defined in the file that holds your ontology. So.
Yeah, Ashley briefly mentioned one of the linked data engines, and there are several of them, but linked data and triple stores is kind of when you're supporting call center type interrogations, they're really useful.
I was just going to mention that since we're talking about ontologies and mapping and all of this, and you don't want to go full ontology, you don't know if you want to do full something, there's a great tool called Protege. It's free. You can go and try it out. It's very easy to do a walkthrough. I would try that out. It has inferencing associated with it. You don't like
I
it?
don't think it's easy.
Yeah.
Oh, well, there's a walkthrough. The
Okay.
walkthrough is better.
All right.
Yeah,
The
there's a
walkthrough does start with, be ready to be confused for a little while.
They
You'll
all-
eventually get it.
Exist in a
Yeah.
state of confusion. for
Stanford
a while.
offers a one-week training class
There you
in
go.
Stanford
Yep.
for $1,500 that'll really get you up to speed in
Yeah,
Protege.
yeah. So if you're not sure if this is something that you want to do, or people on your staff, you don't know if they can do it, I would try that first, see how it works.
Okay, well, we are at time, so I think we'll stop with open questions, but maybe we'll stay here for an extra few minutes if anybody wants to come up with individual questions. As far as the presentations, might I suggest that you all just send them to me and I say, convert them to PDFs first, do your last little tweaks, and I'll email them all to the list. I sent mine already, but I have a spelling or something to tweak too, and I'll send that as well. So that's it. Thank you, everybody, for coming and presenting.